So I have uploaded our last lecture, no, regarding the no, I have introduced you to the IAS, no, IAS, the Institute of Advanced Sciences, uh, machine, or rather designed by John van Neumann. Okay, okay. So ito. So we have the instruction set. Can you see that? You can also open this on your side. No? So you see we have similarities with the instruction set of the analytical engine by Charles Babbage. No? However, there are differences, no? Especially that there are more instructions. And you may know one of the main disadvantages with the IAS is it doesn't have an assignment operator. Okay, it doesn't have an equivalent of the N operation where we can set a value or a constant value to memory. No? So anyway, why is that? Because the IAS is a stored program computer, which means that you write the program on a deck of cards or maybe on an input device, and they will be fully loaded, no, from the deck of cards into memory before they are stored. So therefore, whatever constant you have, you will store it in the deck of cards, okay, along with the source code, because this time your program code and your variables are on the same location in memory, no, or on the same location on your device. You follow? They are both in memory. Unlike in the previous design, no, of Charles Babbage, where the program or the instructions run on the input and the variables are stored in memory. No, so the fetch is from the input, not from memory. No? One of the salient differences, no, is the jump plus, no? The jump plus of the IAS, okay, of the IAS machine. It looks like the CF, no, it looks like the CF and the no the CB, but with the exception that it doesn't work with 1 minus 0, okay, because 1 minus 0 works with CF, right? Before, no, it works with CF. We have that in our no in our in uh, the analytical engine, no, the, the the source code, no, rather the instruction set. We have that. I think it's this, no, dito, no. So in the analytical engine, when we say dito, no, stated, no, okay, 1 minus 1 will not set the lever. Okay, 1 minus 1 0, it will not set. So it works. 1 minus 1 works in the the analytical engine, but 1 minus 1 will not work. Okay, this will not work for the IAS. Why? Because jump plus will only work if the accumulator is non-negative and 0 is considered to be non-negative. Do you follow? In the analytical engine, 1 minus 1 will not set the lever, so therefore it will terminate the loop. Okay, do you follow? So that's the main difference. So we'll have a lot of programming to do here. No, all the programs in the IAS will not necessarily work. Rather, in the analytical engine, will not necessarily work with the IAS. Do you follow? So we have the normal load MQ, which loads the accumulator to the MQ to the accumulator. Everything goes to the accumulator. Okay, goes and comes from the accumulator, being the ingress and egress at the same time. You have load MQ. This is also like L, no, but this time this loads to MQ from a given location. We have store MX, no. This loads the accumulator from a given location, like normal L, the normal L in the analytical engine. And we have load mx. This is the normal load, no, because it loads to the accumulator. Load negative mx, which loads the negative of the location m of x, no, to the accumulator. We also have load absolute, which removes whatever sign it is in m of x, no. Mx is a location in memory, x is an address. Load minus absolute x, which means whatever m of x is, it's converted to negative. We'll use this in our program, no. Then there's a jump. Now there's a jump to the left and jump to the right, because it's not purely vertical, because as I have shown you before, no, the IAS is a 40-bit computer. However, instructions are 20 bits. So in one column or in one record, two instructions can be stored, one on the left and the other on the right. So when you jump, you don't say jump to this address. We also say jump to the left or jump to the right. It's not vertical, it's also horizontal. Okay, because you can jump from left to right. Okay, you have jump plus. This is the equivalent of CF, the close equivalent. It's not exactly the equivalent. And we have the add and sub. No, we have add mx, add absolute, sub mx, sub absolute, and then we have multiply. No, mul m of x. We have div m of x. No, the mul will multiply m of x by mq. Okay, okay, whatever is in mq, and the result is in AC. When we say div m of x, AC will be divided by the m of x. No, that the divisor is m of x, and the result of the division, called the quotient, is in mq. However, the remainder will be stored back to the accumulator AC. Remember AC, no, the accumulator. This is the this was first invented in ENIAC, no, where a register is both used for input and output. We have left shift, which multiplies when you shift to the left, no, being binary, no, when you shift to the left, it will multiply the binary number by 2. Shift to the right will divide it by 2. We also have half stores, store to the left and store to the right. Okay, we follow, no, okay. And then we have here the diagram, no, for the IAS machine, no. This comes from saan ba ito? Sa ResearchGate. Can you see that? Okay, we have compared it to the analytical engine, right? Okay, Charles Babbage. Okay. This is how the looks like, no? This is the diagram, no? So instead of 1 mil, it now has 2 units, no? There's an arithmetic logic unit and there's a program control unit. Okay, the 2 units are designated by the dotted lines, no? In Charles Babbage, this is united into one, converged into one. So in Van Neumann's design, he split the 2, which means that arithmetic and logic will be done in this unit, and data transfer, you must store and will be done by the control unit, program control unit. Do you follow? No. Unlike Charles Babbage design, all of this is done by the mill. This time he split until now, no, he split the functions into 2. Arithmetic take is done by the ALU, arithmetic logic unit, and data transfer is done by the program control unit. You see, we have a main memory, no? So it's connected to the memory, to a register called the memory address register, and it's also connected to the instruction register, no? Because when data transfer is done, you will need to specify an address. Do you follow? Where do you store or where do you load? So you specify where it is being loaded or being stored in the memory address register. And then the value that is loaded or transferred is stored to the memory buffer register. This is sometimes called memory data register. They follow before they are sent to the arithmetic logic unit and stored to the AC. Remember the accumulator AC. This is like ingress and egress at the same time. Okay, stores the result of any operation. We have the program counter. Okay, the program counter generates the address of the next instruction. We will discuss this, no, in one of our future meetings, no. And then we have IR, instruction register. Sometimes, no, when you load data, there are two things that can be loaded. It's either variables or instructions. No, when variables are loaded, the value is transferred to the MBR. When instructions are loaded, the instructions are loaded into the instruction register. For the moment, you disregard IBR. No, it's just a buffer. No, and then it's sent to the control unit. The control unit will execute. No, will perform the execution of the load and store. Okay. Any questions so far? Any questions? Okay, it's in our ano. Uh, excuse me. Okay. Okay. So we have that ano. Okay, that's the actual image from this is from CS ECS California Standard Edu. Okay, and then yeah. Before we proceed with the discussion, how important is the IAS? No? Now, the IAS become the standard design. No? Even until now, it's the de facto concept. It's a de facto concept, which means that all computers are based on the IAS architecture. No? So we have ADVDAC, no? Which lesser known. The important ones were the IBM 701, ILIAC, no? Janyak by Remington Rand Corporation. Remington Rand is a popular company which produces mechanical adding machines. No, you follow? They developed Janyak for Jan van Neumann. No? Jan van Neumann numeric integrator. It's the equivalent of ENIAC, no? But based on the stored program concept. Okay. Then there's many others, no? Okay. Nobody to. And then we will look at the other computers later. Now, particularly we look at the 701, which is one of the most commercially produced, no, stored program computers. Okay, do you follow? Uh, okay. Now you have a programming assignment. I'll have to edit this, no, kasi this has to be postponed. Now let us look at the sample IAS programs. Okay. Hindi ko pa to na-update, no? But we will look at that somehow, no? Is it, no? First, the fourth factorial. Okay. I am adjusting this because I'm going to compare this with uh, the fourth factorial of in the analytical engine. Okay. Ito yung fourth factorial ng ano, analytical engine. Okay. It looks longer, no? The new version. Anyway, what will it do? It will do a repetition of computing the partial product and computing the next multiplier. Diba? That's how we do it, no? But anyway, this time we have to assume that both the variables and the commands are on the same location or on the same location device. No, it's in memory. So which means that no, if this is your program, we will have a command address in memory. So for example, this is command 0, no, and then instead of the ingress and egress, we will monitor the accumulator. Do you follow? Let me just erase the trace first. Okay, do you follow? No? The trace first, and then we have M1, M2, M3, M4. This is the store, no? This is memory 1, memory 2, memory 3, memory 4. Memory 0, this of course M0, no? Horizontally, no? But M0 contains a jump. Do you follow? So this is your memory, no? This is your memory, no? It has a program, no, which also stores the variables. You have usually when you write when in a machine language program, no, the first few parts segments of memory are used to store, no, the variables. They are called the data segment. No? After the last variable, you will start the first command. This is called the code segment. No? So this is our data segment, and this our code segment starts with 5L. Why do we have a 5L? Kasi dapat dito yung 5R eh. Because each memory byte or each memory word can store two instructions, no? Being 20 bits each, because each memory word can store 40 bits. Do you follow? Why is it like that? Because 40 bits can store large values, no? Large and small values in floating point. However, our instructions is very small. No, take note that our instructions is not 20. Can we look at that? No, can we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 pala, no? And then we have an opcode, no? So the opcode is actually how the program is stored in memory because it's in binary. And the symbolic representation is how the programmers write them. But when they are stored in the punch cards, they are stored as opcodes. No? Every instruction has two parts. No? An opcode, which is the equivalent of load or store, no? And an operand, which is the parameter to the operation. So like load MQ has an operand of MQ. Load MQ MX has two operands, MQ and then X. Do you follow? So we now have introduced a new jargon, no? Opcode and operand. They compose an instruction. Okay? An instruction is composed of two parts, no? An opcode and an operand. Do you follow? Any questions? Okay. 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 So, no, opcode and no, and then yeah. So that's why we have this. What's stored here is actually the opcode. We are only writing them in symbolic representation so that we can understand them. Okay. So take note, no. This is the same program we're using. I'm not sure why there's a line. It's in my Excel. Nawawala lang. Okay. So this is a repetition of a sequence that uh, computes the partial product and the next multiplier. Okay. Same thing that we do. And then we have a jump to 5019. 5019 means jump to the left of 5. Because actually itong 5L and 5R are in the same location in memory. 5R is supposed to be here. Do you follow? I cannot write them on a horizontal sequence because it will be confusing to trace it later. Do you follow? Because we are used to tracing the sequence vertically. The problem with IAS is meron siyang horizontal instructions. Okay? Do you follow? So we did a jump so that the next instruction, the next word in memory, the memory location 1, 2, 3, and 4 will not be executed as commands because they are not commands or they are not operations or instructions. They are data. Data variable ito. For example, 1 is used as the next multiplier, which is 4. So dito siya mas-store. No? Okay. And then the constant decrement is 1. Okay. And then we will have an extra, maybe I don't think this is used, no? And then we will have mali itong ano, no? This is not the, no? This is not the this is not the fourth factorial. It's the Fahrenheit to centigrade. No? Anyway, we'll just do this. We know what this does. No, it first computes. Okay, the next multiplier, and then computes the partial product. Okay, let's trace this, no, and then we will do a micro instruction, no. Let's do an equivalent micro instruction. What it does, no. So we jump 509, which means it's 19, which means we go to the left of 5, no? When it's 20 to 39, we jump to the right of 5. Do you follow? Okay, so this is jump to the left. So dito tayo babagsak. We end up here at 5, okay? Which is the first command. Load M1. What does this mean? It always involves the accumulator. AC receives M of memory 1. Do you follow? Do you follow? What is in memory 1? 4. So the accumulator AC here. Okay, let's center this. Make this bold. Okay. The accumulator AC will receive M of 1. So M of 1 is 4. So therefore the accumulator is 4. Any questions so far? That's how it works. No, unlike in the analytical engine, the first load goes to the ingress 1, the second load goes to ingress 2. Now you don't have to specify where it goes because automatically it goes to the accumulator. Do you follow? Remember, we only have one input variable register, only AC. The accumulator AC. We call it now AC. Okay, in short for accumulator. And then we have store M4. What does this mean? Then M of 4 receives AC. This is the micro instruction. Now, all my micro instructions are written this way. No? This means there's a data transfer from AC to memory location 4. So what will happen to this? So the partial product, which is, I think the M of 4 is the result, no? So it will be here, no? Do you follow? Because M of 1 is our next multiplier. Okay? Do you follow? So this is our first partial product. Okay? Or this is the partial product slash result, no? Yan na lang, no? Partial product slash result. 4. So ito siya, no? This is the partial product. Do you follow? Now, the next thing to do is, this is our initial partial product. The next thing to do is to compute for the next multiplier. Okay? We are going to subtract 1. No? So, AC, this sub M2. AC receives AC minus M of 2. Do you follow? Do you follow? AC receives minus M of 2. What is M of 2? It's 1. So what this does is actually 4 minus 1. So the accumulator becomes 3. 3. Do you follow? No? Becomes 3. Because sub M2 will actually subtract the accumulator by the value from M2, which is 1. Our constant increment. Okay? And then we store M1. What do we mean by this? M of 1 receives the value of the current value of the accumulator. Okay? So where's M of 1? This one, and it becomes 3. Okay, now we have computed the next multiplier. Sorry, no, I have to silent this, thing. Sorry for the disturbance. Disregard it, no? Okay. So anyway, no. So we store M1. This is our next multiplier. We will compute the next partial product, mul M4. What do we mean by this? AC receives whatever it has, no? So now you see the concept of the accumulator. It is being used as input and output at the same time. Times M of 4. Kaya lang, no? Okay. So anyway, let's resume now. So mul M4 means multiply the accumulator with its current value. Do you follow? So what the current value of the accumulator is 3. Okay, and the M4 is 4. So that's 3 times 4. Okay, the result will be 12. Do we follow? And we store M4. So M4 store M4 means AC M4 M4 receives the value of AC. Okay, we have done this before. Nandito 5R. We'll just repeat this. Store M4, so 12 will now be stored here. Do you follow, everyone? No? I'm sorry for the earlier disturbance. I should have kept my cell phone silent. Anyway, I have fixed it already, you know. Load M1. So load M1, what do you mean by this? AC receives M1. We have that already, no? This is what it does. AC receives M1. Okay? So, anong content nito? Okay, M of 1 is, what's M of 1? It's now 3, right? So AC receives 3. Okay, do you follow? 3. Okay. So AC now becomes 3, no? And then we sub M2. M2 is this is our way of computing the next, no? So we already have a sub M2. So this means AC receives, sorry, bakit ayaw? Sub M2. Control C. This is AC receives AC minus M of 2. What is M of 2? It's 1. AC is 3. So this means 3 minus 1. Do you follow? Right? So the accumulator becomes 2 and we store it to M of 1 because this becomes our next multiplier. Or rather 2. Okay? Any questions so far? No? Okay. And then we will load M4 because we are now also going to compute the next partial product. It's a repetition after the multiplier, partial product. So load M4. So AC receives M of 4. Ano, store M1. Nandito na. Load M of 4. Do we have a load M of 4 before? We don't have. No? So we just use this. M of 4. Instead of using M of 1, we'll say M of 4. We forgot the micro instruction for this. So this is M of 1 receives AC. Okay? Do you follow? AC receives M of 4. So M of 4, what is the value of M of 4? It's 12. Okay? And mul M1. What do we mean by this? AC receives AC times M of 1. Okay? Instead of M of 4, we'll say M of 1. Okay? Do you follow? Okay? M of 1. So the actual content is 12, which is the current value of AC. And what is M of 1? M of 1 is our multiplier, which is now 2. Okay, 2 ito, no? Ito siya, oh. Ito siya sa M of 1. Okay? This is M of 1. So it's 12 times 2. So now the accumulator becomes 24. Do you follow? And then we store M4. M4 receives AC, this one. You just copy this. Do you follow? So therefore, the value of AC, which is 24, is now copied to M of 4. It's 24. Do you follow? I hope you are following, no? And then load M1. AC receives M1 again because we are now going to compute the next part, the next multiplier. That's what AC receives M of 1. So what is M of 1? M of 1 is 2. So we now have AC as 2. Okay. Sub M of 2. So AC receives AC minus M of 2. So ito. Do you follow? That's what it does. So the current value of AC is 2. M of 2 is 1. So this is 2 minus 1. The actual content, the result is 1. Do you follow? And we store this to M of 1. So our next our next multiplier will be 1. Okay? Do you follow? So this is M of 1 receives AC. This is it, no? Store M1. M of 1 receives AC. Okay? Load M of 4. AC receives M of 4. Ito. Do you follow? No? AC receives. So, you know, all data transfer will always involve AC. Unless otherwise specified, like load MQ. Do you follow? No? Load M of 4. So, AC receives M of 4. What is M of 4? It's 24. So, this is now 24. No? Mul M of 1. So, AC receives, it's AC times M of 1. Right? So, the actual value for this is 24 times 1. Do you follow? So, the accumulator becomes 24. And then we store M4. The resulting value is our final value, which is 24. So store M4 means M4 receives AC. Do you follow? No? Do you follow? I'm going to upload this. Okay. Now later we are going to convert this into a loop version. It's not easy, no? I think we'll consume a whole session for this. It's not easy because there's a difference between jump plus and there's a very subtle difference. In fact, no? A very subtle difference between CF and jump plus, no? Ito ang problema natin dito kasi ang yung ano nga yung 1 minus 1 will not set the level, the ano, iba yung ano, we'll have a problem because 1 minus 1 will not set and it will do the opposite in jump plus because 1 minus 1 equals 0. It's still a positive, it's not a negative. Okay, do you follow? So ito. Now I'd like to show you the Fahrenheit to Celsius. Ano, it's rather straightforward. Fahrenheit to Celsius, straightforward lang ito. No? So what this is our initial value. We are going to convert, no, 132. Okay, Fahrenheit to Celsius. So the formula is Fahrenheit times 32. Okay, 32. 100 Fahrenheit minus 32. Okay, times 5 over 9. Do you follow? Okay, so we are going to jump to 60 to 19 dito. This one because 132 is our initial value in M1 and 32 is a constant, another constant which is 5, and the last constant which is 9, and we will store the result in M of 5. So therefore we will jump to the left of 6. Okay, so load M1. M1 means AC receives M of 1. So in which case, the actually happens is AC receives 132. So this becomes 132. And then sub M2 means AC receives. What do we mean by sub M2? AC receives AC minus M of 2. Okay. M of 2 is 32. So AC becomes 100. And then we have mul M3. We have AC receives AC times M of 3. What is M of 3? It's 5. Okay. So 100 times 5 becomes 500. And then we have div M4. So this means AC receives whatever its current value is divided by M of 4. So M of 4 is 9. So actually this is AC receives AC divided by 9. So this is 55.556. And then we store the result to M of 5. So we have this is M of 5 receives AC. Do you follow? So M of 5 becomes AC and this is our final value. Okay, do you follow? Any questions so far? Let's save this somewhere. I'm going to upload this later. Do you follow? Okay. Ang final answer, sir, is the last na M, not necessarily to the last. It depends on where you want to place it, as long as you indicate that this is the result. No, you're free to place it anywhere as long as it's correct. Okay. Okay. That's a question by Asombrado. No, do we have to store it to the last, the final result? Not necessarily, because in actual programming you can use any variable, and the variable is actually converted into an address. Okay, so we're really not sure which is place, but in here we just designate the last. You can designate any position in memory, no? Because in actual programming languages we don't know the address anymore. Okay, because we know the variable names. Okay. Now, well, how do you have a halt? A halt is actually a jump to itself. So basically say jump 8. Kasi wala tayong ano eh. 8 is R, no? So this is 20 to 39. You follow? So this will just perpetually jump to itself. That's what we mean by a halt. You follow? Okay. Because the IAS doesn't have a halt command. Okay. So this, do we have a halt here? We have a halt. This is 14L. Say jump 14 0 to 0 to 90. This is a halt. Okay. You follow? Meters to feet. Madali lang naman, di ba? How do you do that? This 4 meters, we just multiply this with 0.328, so we'll just jump to the 4L. Okay, load M1, so AC receives 4, and then mul M2, we multiply it by 3 point, and then we store it to to M3, M3 being our result. So can we just insert the what this means? This means AC receives M of 1. This means AC receives M of, rather, AC times itself times M of 2. And then store M3. This means M of 3 receives AC. Okay, do you follow? Do you follow? Okay. Do you follow? Now, let us attempt to make. We'll just attempt to make anyway. No? Hanggang oras ba tayo? Ano tayo, no? Let's look it up in the AIS. AIS, hindi IAS. This is 4-100. Okay, so 9:20 to 10:50. Okay, we have a few minutes more. Okay. We have 35 minutes. Okay. Anyway, we cannot finish the whole program. Anyway, we'll just try to make an attempt, and I will explain to you as a certain programming concept by next meeting. No? I'm going to upload it to Daigler. No? So we can copy. No, let's open our Excel, and then let me open our fourth factorial. No, ito. We can copy this. No. This is the fourth factorial. Walang loop, no? without loop. Anyway, we can do a loop, no, by using the concept of the average, no. Actually, there's also a looping example in the website, no, in our source site. Okay. So anyway, ganito yan, no? Let me just copy this to a new, ano. Okay. This is the first version. This is our first attempt. We will have a problem later, no? What we do is actually we will. This is loaded. This is a conversion from the analytical engine. Do you follow? Do you follow? Okay. We'll analyze this. Okay. So this is just a repetition of compute the next partial product and compute the next multiplier. Okay. So ito yon, jump 16 because this is our partial product, no? Our decrement, our next multiplier is M3 dito. Do you follow? Our result. This is an example where the result is stored in M1. Do you follow? Do you follow? Okay. So we have a halt here, oh. No? Do you follow? This is a shorter program. You see, this is a much shorter program because this is a better computer. Do you follow? So this is the first pass. Okay. Trying to figure out how to fit this in on screen. It fits now, right? So yeah, this is pass number 1. This is pass number 2. Let's do that. This is just a repetition, by the way, of computing the partial product and the next multiplier. No? So first is we have load M1. Now our partial product is in M1, which receives the answer. Our decrement is 1. The next multiplier currently is 1. Okay. So load M1. This is actually, let's change the, no? Let's change this. This is, it's too big. It's calibre 18. So Arial 10 na lang tayo. Calibre lang. And then we'll make this, 18. Okay, do you follow? Okay. This is the micro instruction. Load M1. Load M1 means AC receives M of 1. Do you follow? Okay, so AC becomes 4. And then we have mul M3. What do we mean by this? AC receives AC times M of 3. Do you follow? Do you follow? So the actual content is 4 times 1. M of 3 is still 1. So this becomes 4. And then we store M1. M of 1 receives AC. Okay? So this is now M of 1 becomes 4. Okay? Which is our first partial product. And then we have computed the partial product. The next thing to do is compute the next multiplier. So we load M3 because it's 4. It's, what is M3? Okay. We load M3. Mali ito, no? We should be load M4. Okay. Load M3. By the way, M3, we should initialize this to 4. Dapat 4 ito. Sorry for that. Okay, because when we say load M3, we say AC receives M of 3. Okay, and M of 3 is now AC becomes 4, and then we subtract M2, so AC receives AC minus M of 2. M of 2 is 1, so we'll have 4 minus 1, so this becomes 3. Okay, and we store M3. M of 3 receives AC. So when M of 3 receives AC, do you follow? Our next multiplier is 3. Okay, do you follow? Okay, and then we say jump plus. Okay, jump plus 6 to 19, which means we will go back to 6L uh, if the accumulator is positive or non-negative. Okay, this is just a translation from our analytical engine verse program. Do you follow? Do you follow? Pabalik tayo dun sa taas. Okay? And then we will, other than that, if it's not negative, it's already negative, we will halt. Okay? Do you get my point? No? Okay. So pass number 2. We'll go back to 6L. So we load M1. Load M1 means, kopyahin natin ito lahat, no? It's still the same. Balik lang naman eh. You follow? AC receives M1, so AC becomes 4 because M of 1 is 4. M of 1 is 4, and then the last value of AC, by the way, is 3. So we don't have to do that. M of 1 is 3, no? Okay. Mul M3. M3 is is now 3. Take note, no? It's 3. They follow this. It will become 4 times 3, and this 12, and we store M1. So our next product is 12. Do you follow? Do you follow? So we have computed the next partial product, which is 12. The next thing to do is to compute the next multiplier. We load M3, which is 3, and we sub from M2. M2 is our 1. This is just a repetition. It's actually 3 minus 1, so AC becomes 2. And we store M3, so our next multiplier is 2. Okay? Do you follow? And then we jump plus. This is the same story, no? We jump plus 6 to 19. What do we mean by jump plus? Check the accumulator. Is it non-negative? Yes. So which means we will go back to 6L. So this is now pass number 3. Okay. This is the third pass. We'll just copy this because this is the same story. And we'll find out that later we will have a problem at the end. Okay. We'll have a problem at the end. Okay. So anyway, let's do that, no? So our M1 is 12, our M2 is 1, our M3 is 2. Okay, you follow? So load M1, M1 is 12, so AC receives 12. Mul M3, M3 is 2, so we will actually have 12 times 2. So the accumulator becomes 24. We store M1, so our next partial product is 24. Do you follow? And then we compute the next multiplier, load M3. So M3 is 2. We sub M2, which is 1. So what the next multiplier is now 1. Okay? Jump plus 6 to 19. What is the value of the accumulator? It's a positive, no? So we'll repeat to pass number 4. Okay? We'll repeat to pass number 4. This now, pass number 4. And obviously, we have the same set of micro instructions. We'll just copy this, the same story. Now, this is where we will have a problem. Later, no, in a few steps, we will see the problem. So load M1, so AC becomes 24. Mul M3, M3 is now 1, right? Because this is now 24, 1, 1. Okay? Transfer it here, no? 24, 1, 1. Okay? So 24 times 1 is 24. And we store M1. So our next product is 24. And then we will compute the next multiplier. So our current multiplier is 1. We sub M2. This 1 minus 1. This is 0. We store M3. This is 0. And now here's the question. What will we do if we have a jump plus 60 to 19? Will this jump back or will it terminate to 9R? Remember, jump plus will jump if the value is non-negative. This is not a negative. So we will go back. Now we will have a problem here. Kasi pagdating natin dito, 24, now we multiply with M3, this becomes 24 times 0. And our product will become 0. So obviously, our final result will become 0. Because our problem is this 1 minus 1. We should not have jumped to 16, or rather to 6L, right? Do you see the problem here? Now, for the analytical engine, this will work because 1 minus 1 will set, so it will go back. But this time, it will not set for the IAS because of that subtle difference. In 1 minus 1, okay ito sa analytical engine, it's not yet okay for it's not yet okay for the IAS. Do you follow? So what do you suggest? Okay? What do you suggest here? I'm postponing the assignment, no? Because I've solved this anyway already, no? Because I'm going to introduce a concept, no? A programming technique that will solve this. Because no matter what you do, as long as you try to convert that version from the analytical engine to this version, you will be desperate. It will not work. You will have to need another strategy in order to make this work. What do you suggest anyhow, no? Okay? So, your programming assignment will be to do this. Postpone ko ito kay wala tayong meeting. Wala akong meeting sa Wednesday. We can postpone this until August 5, where we will have our first meeting next week. We may not meet on the 3rd na lang siguro, no? We'll meet on the 2nd. We'll not meet on the 3rd because most probably this will be the orientation of the new, Okay? So we will move this to 5, no? Here is your programming assignment. Write a program to compute the sum of the first 4 numbers. It's okay. It's like the factorial program. It will convert Celsius to Fahrenheit. The third is write a program to compute the average of the first 3 numbers with loop and give a trace. Now, our problem is we cannot use our factorial program because it doesn't even work. They follow. We know that computing the average is like computing the factorial, but we cannot even use it because it doesn't work. We still have to revise it. Okay? So can we move this to July 5? Or rather August 5, no? I-edit ko na lang. I hope I can edit this. Okay. Now the solution to this is a long story. I'm going to introduce new sources, no? So you're doing programming, no? Everyone, are you doing programming currently? August 5, okay? August 5 at 8 o'clock. Okay. The cut-off date is also August 5. Okay. Okay. I think this is fine. Okay. Any questions so far? No. So the deadline for the assignment is August 5. We will meet August 3 na lang, no, to discuss the Kasi kung August 3 ako dito, pwede ako dito mag-orientation. The schedule for the second batch is either 3 or 4. So I will meet the other group. I will meet you here to discuss, and then we'll have. Okay, so we can set this to we can set this longer. Okay, so what we will do next week is we will meet on the 3rd, but we will not meet on the 5th. Do you follow? Or we will not meet on the 3rd kasi I may have my orientation here. So August 5, we will meet on the 5th. Okay? We will not meet on the 3rd because I will have my orientation here, and we will meet on our next meeting will be August 5. Pero ang problema nito, no? Kung sa August 5 tayo we'll meet on the 3rd, mag-meeting. Hindi pwede. Gusto ko i-discuss ang approach on August 3. Okay? So i-discuss ko rin si other section dito. So we will only meet once next week. That's August 3. Okay? Because I will do my orientation na lang on August 5. Okay? Do you follow? I will make an arrangement. Yes, because let me show you the once lang tayo mag-meet talaga next week. Gmail. Because there's a new batch of students, by the way, first year, no? There it is, no? I'll show you the email, okay? Ito. August 3 and 4 will be the orientation of the second batch of first year students. Okay? So if you will not meet on August 5, what we'll do is I can set this to 9 to August 9. They follow? I can set the deadline for the August to August 9 so that you will have a long time to study this. Okay? I'd like you to solve this problem. This is not easy, no? By the way, no? You cannot Google this, I'm sure, no? Because I've Googled this several times and there's no Google. Okay? So we can do this in August 9. Anyhow, no? Okay? So I will do my orientation on August 5 so you will have time to work. We will meet on August 3. So to discuss the concept we need to solve this, okay? So August 9, is that okay? Hindi natin, unfortunately, we can't discuss it anymore, no? Kulang 10 minutes is really lacking. I'm going to need a whole meeting to discuss the strategy, okay? So we'll make this August 9 because we will not meet on August 8, 5. I will do my orientation. I'll just make the arrangement, no? Anyway, pareho lang naman. If I'm going to do it, the orientation on August 3, and then we will discuss on August 5, you will be delayed, okay? Because you will not know how to solve it until August 5. So matagal masyado. It's too long. So I'd rather have my orientation on August 5 so that by August 3 we will meet and discuss how this thing is going to be solved. Okay? Any questions? No? Tama ba yung aking pagkaso, So August 9 na ito? Yes, no? August 9 is the deadline. Everyone, no? Listen. I'll chat you of the next assignment. Okay? Any questions so far? So we're 10 minutes or 15 minutes short tayo. I'm sorry for that, no? Okay, so we'll have to move to short hour, no? To end our session early today, no? I will upload this to Dagler. Okay, and the updates to the program. Any questions so far? Okay. So thanks for coming. Okay. See you next meeting. Our next meeting is August 3, okay? Oh, sorry. Ano ba ngayon? Let me just make sure it's 29. Yes. Our next meeting is August 3. That's because, yeah, I will orient. Ito ang problema dito, yung mga new. The orientation is supposed to be 3 and 5. But since I will meet you on August 3, okay? Okay. So August 2, so wala rin akong klase pala sa August 2 because no, it's 2 p.m. Yes. And I will have my class at 1:30, so walang klase sa August 2. For first year lang ito, no? I'm sorry, no? Do you follow? Only for first year students. I guess there are freshmen here. Okay? So August 2 and August 5 walang klase. Okay? Any questions? Suarez is late. Suarez. Okay. Anyone else? Can you just chat me? Narca? I think I've checked you already. Do we have Asylum? Let me look at the participants. Okay, wala si Asylum. Asylum has been absent for long already. Kalubag. Is Kalubag here? Yap is here. Bigman. Bigman is here.
Present.
Estores is not here. Lim. Lim is not here. Nakamatsu. Not here. Navarez. It's not here. Maybe offline. Valmoria. Are you here? Wala, no? So, yeah. Any questions so far? So our next meeting is August 23. That will be our only meeting for that week. So that will be time for me to discuss a new programming concept which you can use, no? Because may problema nga tayo. We have a problem with the difference between CF and Jump Plus. No? They are not the same. Okay? Any questions so far? So see you everyone, no? On August 3. Okay? Everyone? We will not have a class, but me, I will have an orientation, okay? For the new students. Okay? So bye everyone. And see you next time.
Thank you po, sir.
Thank you,
Thank you,
sir.
sir.
Goodbye.